Today's topic, the product rule for derivatives. The product rule for derivatives. The derivative of f of x times g of x with respect to x is equal to f of x times the derivative of g of x with respect to x plus g of x times the derivative of f of x with respect to x. This means the derivative of the product of two differentiable functions is the first function times the derivative of the second function plus the second function times the derivative of the first function. Examples. Number 1, f of x is equal to x cubed times the quantity 6x squared minus 7. The first function is x cubed and the second function is 6x squared minus 7. The derivative of f of x is equal to the first function times the derivative of the second function plus the second function times the derivative of the first function. So this is now equal to the derivative of f of x or f prime of x is equal to x cubed times the derivative of the quantity 6x squared minus 7 with respect to x plus the quantity 6x squared minus 7 times the derivative of x cubed with respect to x. This is now equal to x cubed times the derivative of 6x squared is 6 times 2, that makes 12, and then subtract 1 from the exponent 2, so we have 12x. The derivative of 7 is 0, 12x minus 0 is 12x, so times 12x plus the quantity 6x squared minus 7. The derivative of x cubed is 3. It is understood the numerical coefficient is 1, so 3 times 1, and then subtract 1 from the exponent 3. So this becomes 3x squared. So the derivative of x cubed with respect to x is the 3x squared. So multiply 6x squared minus 7 by 3x squared. Do the indicated operations. X cubed times 12x is equal to 12x raised to the exponent of 4. Multiply 6x squared minus 7 by 3x squared using the distributive property of multiplication. 3x squared times 6x squared is equal to positive 18x raised to the exponent of 4. 3x squared times negative 7 is equal to negative 21x squared. Combine the terms that are similar. 12x raised to the exponent of 4 is similar to positive 18x raised to the exponent of 4. So we can combine them. That is, we can add their numerical coefficients. So we have 30x raised to the exponent of 4 and then minus 21x squared. So the answer is 30x raised to the exponent of 4 minus 21x squared. Number 2, f of x is equal to the quantity 3x squared plus 4 times the quantity 5x squared minus 2. The first function is 3x squared plus 4, and the second function is 5x squared minus 2. The derivative of f of x is equal to the first function times the derivative of the second function plus the second function times the derivative of the first function. So this is now equal to the derivative of f of x, or f prime of x, is equal to the quantity 3x squared plus 4 times the derivative of the quantity 5x squared minus 2 with respect to x plus the quantity 5x squared minus 2 times the derivative of the quantity 3x squared plus 4 with respect to x. This is now equal to the quantity 3x squared plus 4 times the derivative of 5x squared is 5 times 2, and then subtract 1 from the exponent 2, so this becomes 10x. The derivative of 2 is 0, 10x minus 0 is 10x, so times 10x. Then plus the quantity 5x squared minus 2. The derivative of 3x squared is 3 times 2, that makes 6, and then subtract 1 from the exponent 2, so we have 6x. The derivative of 4 is 0, so 6x plus 0 is 6x, so times 6x. Do the indicated operations. Multiply 3x squared plus 4 by 10x using the distributive property of multiplication. 10x times 3x squared is equal to 30x cubed. 10x times positive 4 is equal to positive 40x. And then multiply 5x squared minus 2 by 6x also by using the distributive property of multiplication. 6x times 5x squared is equal to positive 30x cubed. 6x times negative 2 is equal to negative 12x. Combine the terms that are similar. 30x cubed is similar to positive 30x cubed, so we can combine them. That is, we can add their numerical coefficients. So this is equal to 60x cubed. Positive 40x and negative 12x are similar terms, so we can combine them. Positive 40x, negative 12x is positive 28x. So the answer is 60x cubed plus 28x.